Okay, this looks pretty messy, and it totally is right now. Just a couple of power supplies, 12 volt power supply, 5 and 24. 24 is the only one we're really using right now. Here is the DirectLogic DL06 PLC with 4 card slots there. Slot 2 and 4 are occupied with an 8 input analog input card and a 4 output analog output card. That's intended to send between 0 and 10 volts over here. It's disconnected and bypassed right now so that I can tune the speeds and the settings on the variable frequency drive. But ultimately it'll be the analog output card that sends the signal to the variable frequency drive that will then control through these 2 relays, which will allow me right now it's in reverse mode, and then it'll switch over into forward mode depending on whether or not the set point is greater than or less than the process variable. So right now that's the actuators moving in because the set point is larger than the process variable. Right there, that's the actuator should be able to move out because the set point is less than the process variable. So the power from the variable frequency drive, it's just going to modulate the frequency of a 24 volt pulse through the power through this to the actuator down here. Okay. So the idea is that the PLC will monitor the difference between the process variable, which is the actual PSI of the brake system, the pressure, and then it'll take a set point and it'll constantly be doing the calculation to determine the difference between the set point, which is where I want to go, and the process variable, which is where it's at, and then it'll output the appropriate signal so that this actuator will adjust. Now, of course, this is just like your foot on a brake pedal. As you push a little harder, so the variable frequency drive allows me very fine control, as you can see. And of course now I'm out at the extent of my range, and so if I want to go the other way, turn this all the way down, I'm going to simulate that the set point now is greater than the process variable by turning that knob. And now over here, this is simulating the output signal that'll be the output of the calculation, and will go to the variable frequency drive. And this right here is simulating, well, it's telling me what the voltage is for the speed so that I can make those adjustments. So as I turn this knob with my right hand up, you can see the voltage increase. So right there, if the analog output card is sending, 0.5 volts, that's the speed that I'm getting, which isn't very fast. And as I increase and the analog output goes up, the speed increases. I've got to change directions now. All the way up to 10 volts. So that gives me a pretty dynamic range of speed. We got to switch back to greater. There we go. Pretty dynamic range of speed and control. So, as you can tell, what the issue was, we were able to get between 0 and, I don't know, 800, 1500 PSI on that brake system within about 1 inch to 2 inches of travel, which means that if you've just got to hit this with a full 24 volts through the speed of a relay, it's going to overshoot the PSI that I actually want. Whereas now, I can move this up 1 millimeter, and it'll be interesting to see the kind of resolution that I can actually get. But it should be something like I don't know, maybe as little as a single PSI. That is fine movement on a 24 volt actuator. All thanks to the variable frequency drive and the DL06 PLC and its PID calculation. Alright, that's it.